This set of videos will be about section 5.2, logarithmic functions and the properties of logarithms in the book College Algebra in Context. The general logarithmic form y equals log base b of the x converts to exponential form that x equals b to the y power. In both forms, the number b is the base and y is the exponent. y equals b log base b of x, and y is also the exponent in x equals b to the y. Thus, a logarithm is an exponent. The logarithm is the exponent. And in y equals log base b of x, x is called the argument, or sometimes we might want to just refer to it as the number. Another way to look at this is if we go with this equation, bin, b is the base, e is the exponent, and n is the number, and that changes to the log form that e, the exponent, equals the log of base b to the number n. So these might help you remember what's what as we're doing things. When we graph the logarithmic function, the logarithmic function is the inverse of the exponential function. So if we have the equation y equals log base b of x, the x-intercept is 1, 0. The y-intercept there is none. The domain is from 0 to infinity. The range is all real numbers. And the y-axis becomes a vertical asymptote. In this case, we're using a base b where b is greater than 1, and here we're using a base b where b is between 0 and 1. Function. Y equals log base 5 of x. Again, now we need to graph this. Notice I picked the y values first because they're actually the easier ones. So if x is 5 to the negative 2, then x would be 1 over 5 squared, or 1 over 25. If x is 5 to the negative 1, then it's 1/5. If x is 5 to the 0, then it is 1. If x is 1, it's 5, and x is 2, it's 25. Graphing these, I'll number by 2's. We have 1/25 negative 2. So it's really, for this size, just right next to the axis. Negative 1/5 negative 1 would be also very close. 1, 0. 1, 5, 1. And 25, 2 would be clear out. So that my graph looks like this, and I have the asymptote as the y-axis, x equals 0. We need to say how this compares with log base 3 of x, find the domain, and graph the function. Well, this plus 3 with the x is going to mean I'm moving 3 left. And what that does is move, remember this graph by ones, it has moved the vertical asymptote from the y-axis to x equals -3. So my points for the log base 3 would be 1/3, -1, 1, 0, and 3, 1. So 1/3, -1 would be here, move it over 3 places. 1, 0 here, move it 3 places over. 3, 1 would be here, move it 3 places over. You could also do 9, 2 would be here, and move it 3 places over. So this becomes my graph, and the domain here is now from -3 parentheses to infinity. We're going to be working with the same basic function, log base 3 of x. Find the domain. Well, this +2 means I'm going to be moving it to right, and this 4 plus means I'm going to be moving it 4 up. To right has essentially moved my asymptote to x equals 2. Move that vertical asymptote. We'll still go with those same 3 points. Our regular 1/3, -1. Move it to right, and 1, 2, 3, 4 up. Be about right there. Our point 1, 0, 1, 0 moves to right, and 1, 2, 3, 4 up. Our point 3, 1 moves to right, and 1, 2, 3, 4 up. And now we have, this is the graph, and the domain, as we said, will run from 2 to infinity because we moved the asymptote.